Circle, ellipse, hyperbola. How do I get to this funky hyperbola equation? Notice there's two slightly different forms of the hyperbola equation. I'll move my mouse out of the way.
Is that not just the eclipse formula?
What's the difference between that and the ellipse?
Negative.
Not eclipse, ellipse. What's the difference between the ellipse and the hyperbola?
Negative.
A negative sign. One negative sign completely changes the shape of this graph.
What does a hyperbola look like again? It's like
You're about to find out.
that. This looks fun.
Uh-huh. T greater than or equal to 0. Put a where in. I will do the derivation of the formula so you can see where this comes from. I did not want to try this with just weird stuff because you aren't even going to see how we got that from the shape of the hyperbola. So I'm just going to start with this and show you where we get to. I'm going to start the same way. X equals y equals 1 plus 2 sec t. Y is 3 plus 10 t. How am I going to link sec and tan? Sorry.
Nothing.
Without trig identities or something?
Which trig identity are you going to use to link sec and tan?
The tan squared plus 1 equals sec squared.
Correct. Tan squared t plus 1 equals sec squared t. Okay, I better rearrange this for sec and tan. Go.
Oh, it's going to look like that.
Like what?
What's on the board?
It is, yes. Sec t must be x minus 1 over 2 and tan t is y minus 3. Plug them in, simplify.
Do you want one on the right?
Rearrange until it looks like one of the two options you've got on the formula sheet. Go. This is a hyperbola. It's got a minus sign. If you look at this and you've got sec and tan, or cosec and cot, you're going to end up with something like this. Where this minus sign is tells you which of two options you get. Ask your graphics calculator to plot this. You'll have to plot as a relation.
That looks fun.
Yeah, across a little bit. It's got to be a bit more pointy. I do more like parabolas. It's supposed to line up, Mr. BM. Seriously, come on.
I wish he's a touch screen.
You found it? Yep, good. All right, what's the relationship between position and shape of this graph and the numbers in this equation?
Wait, let me just think.
What was the question?
What's the relationship between these numbers and this shape and position?
The center point is 1 and
2.
3.
1, 3. This point in the middle is 1, 3.
2,
Have a look up there if you want an accurate one.
3, 1, 3. Yes.
What does this 2 tell me?
The horizontal.
Yeah, look, exactly, yeah. Horizontal semi-axis, agreed. It's the distance between that centre point, where you get right 1, and where the curve meets. So this distance is 2.
Oh.
What does this one tell me?
Vertical. Semi.
Yeah, it's harder. It's how
But the
how sharp
direction.
they are, right? It's harder to
So
get
the
right.
bigger the number, the steeper.
Try it. Change it. What do you think happens if it's the other formula, this minus that?
Oh, the 2 and the 1 is going to be the other way around. Not the 2, like the horizontal
Try it.
direction, and the thing is going to
Try it. What happens if I swap this and make the other one negative? If I make the x one negative, I end up with that shape instead. You just have to either work it out, plot it if you've got a calculator, or just learn and remember. If the y is negative, I'm going this way. If the x is negative, I'm going this way. I'm going this way. That's the difference between those two formulas. That's hyperbolas. We haven't quite finished.
Of course we haven't.
What is my parameter actually doing here? The easiest way for me to do this is to do it parametric up there. See if I can remember how to do this.
And it always starts there? Or is that just tan and sec?
If it's tan and sec, you can work out where it starts. Just put t equals 0 in and work out what the numbers are.
Yeah.
So those bars, they're not infinite, are they? Because if they were infinite, they would never reach the other point, wouldn't they?
They go all the way to infinity.
So then how do they jump?
At infinity. Every point in the universe is connected to infinity. If I go infinitely far this way, I'm at infinity. If I go infinitely far that way, I'm at infinity. What's really happening, Julia? What is sec pi on 2? That's 1 over
Oh, there's a
cos,
subdividing by 0.
which is 1 over 0. Uh-oh! It's not defined at that point. It's not continuous.
Right.
It goes this way, as close as you like to pi on 2. At exactly pi on 2, it doesn't exist.
So it jumps there.
Just after pi on 2, it's way down here, close to infinity. Then it comes up here. At 3 pi on 2, you get closer and closer and closer to infinity.
Right.
At exactly 3 pi on 2, it doesn't exist. Just after that, it's coming back up here.
So it only stops where it's undefined.
There's a couple of points where it's not defined. Or if you prefer, it wraps around at infinity, whichever way you like to think of it.
Okay.
That's hyperbolas.